Okay. No, not before. I've just started it. Huh. It was, well, that's okay. The video doesn't pick up you guys really well anyway. Okay, so we are starting 4.6. Now we are moving on to geometric sequences. I would say they're different. I wouldn't necessarily call them harder. I'd call them different. All right, this is just a lesson opener though. This is not in your books. And it's up to you if you want to write it down. It's just, again, we're reviewing the building blocks here. So if I ask you, find the next number in this, that was wrong, sequence. Struggle with my cues. I don't know why. All right, so let me give you the sequence. So number one is what's my next number?
32.
32. Can you see the pattern?
It's multiplied by 2.
Right, we're multiplying each term in the sequence by 2. We're not adding.
Oh,
right?
I just thought 8 plus 8 was 16. So then, oh, well, maybe not bring this on my computer.
But you see that 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that means that your difference is not common because it has a different value every time, but there is a pattern to that difference, right? So the difference each time is the previous term multiplied by a number, which gives you the new one. So you still have a pattern, but it's not a common difference. So that's what we're looking at a little bit. That's what we're going to be looking more into as we get into geometric sequences. Let me give you another one. This one's easy. 10. Now, would we call this an arithmetic sequence? Or is this different? We have a common difference? Yeah. It's not an arithmetic sequence. All right. Let's see what else we got. What's my next number?
27 times 30.
Okay. What's 3 times?
66.
What's 3 times 2?
What?
What's 3 times 2? 6. So 3 times 20 would be 60. Did it stop ringing? Okay.
71.
And then what's 3 times 7? 21. So what's 60 plus 21? 71. What's 6 plus 2?
81.
81. There we go.
So you were wrong.
No. So it's 81. Yeah. So what's our difference here? What are we doing between these terms in the sequence? Yeah, we're multiplying them all times 3. Okay, we all see that?
Or, you could just be a little bit smart by it. You could say, well, 9 times 3 is 27, and if you're going to multiply 27 times 3, so that's basically 9. So you got 9 times 9 is 81.
Yeah, they're all related, but that's not the pattern we're seeing. You had to jump from one thing to another. Yeah, that's a 26. 3 times 27 is easy. That's an easy one. Number 4.
Hey, the reason why is I times it by 2. 2 times 27 is like 54.
And 54 plus 27.
See, I got confused.
Yeah, because you didn't multiply the 7 times 3, you multiplied times 2.
Yeah.
Y'all are froggy this one.
Yeah.
See, I did the same thing, but I still multiplied the 2 times 3.
What about this sequence? What's the next number in this sequence?
Divided by 2.
116.
116.
Oh.
So every one is being multiplied by 1/2.
I saw something, I was like, yeah.
Right?
Why does it say one? One times a half.
What do you mean?
is a half. Everybody.
1 is the first term in our sequence. Well, 1 times 1/2 is 1/2, right? And then I keep going. And when we multiply, you multiply your numerators. Well, 1 times 1 will always be 1, but your denominators will continue to grow. Okay. In value. One more, and then we'll get to the good stuff. They're like, no, let's just stay where we are.
Oh, I suddenly don't like this anymore.
You suddenly don't like this anymore. This one's easy.
-2.
Yes, very good. Yes. Right, so we are multiplying because anytime you multiply a negative times a negative, you end up with a positive. So every other one is always going to be.
Oh, I thought we were trying to find out. Yeah.
You got confused on what we were doing.
Yeah. She said negative 30 pounds, like.
What? Right.
And you said it was right. I was like, how did you miss?
You're lively this
How
morning.
did you miss?
How did she do that? Yes, okay. Yeah, so anytime you're gonna multiply terms in a sequence by a negative number, they're gonna alternate between negative and positive. Because every other one, you're gonna be multiplying that negative times another negative, so you're gonna end up with a positive. Cool, all right, we good. We got our brains in the right place. All right, we're warmed up. Let's move into the actual lesson. So on page 158, they explain to us the definition of a geometric sequence. It is a sequence of numbers whose successive terms differ by a constant multiplier. That makes sense to everybody? Right. Just wah, 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 wah. Yeah, is that what you heard? Yeah, so let's break this down. What does a successive term mean? The next. Think of a successor. Who's the next king? There's a successor, so it's the next number. So remember, well, we don't exactly have monarchy. Well, we as Americans don't have monarchies anymore. But yeah, I mean, we see it. We see it. So if I have the sequence, let me just show this to you guys. If I have a sequence, and I'm looking at the number 4, then 2 is the preceding number. 4, that's a preceding term. 6 is the succeeding number of 4. So that means it's the succeeding. Now we also have success, but this is talking about successive. So this is a preceding number. Number 2 is preceding 4, comes before. Number 6 is a successive number because it comes immediately after. So this means that in your sequence, where the difference between these numbers include a multiplier of some kind, which the one I've made here does not, but we can pretend it does. So that, like we saw in our first examples, if you're multiplying by a common multiplier, then you have a geometric sequence. Whereas when we had our arithmetic sequence, we were just adding. Yes. Yeah, that's, I mean, these are very similar. All right, so the constant multiplier, which means just the number that each term is getting multiplied by to create the next term, is called a common ratio. So that's common ratio is what we call the multiplier that's going to be used in a geometric sequence. All right, so let's look at some examples here. First off, just like we did in 4.5, you've got a little graphic there that gives you your equation. So go ahead and make sure that equation is in your notes and you're recognizing that a geometric, we call that sequence formula is, oh, equal sign get confusing in math. Any term at position n is equal to the preceding term, or an minus 1 times the common ratio. So you can see this is very similar, but instead of adding, we're multiplying. This is your common ratio. And instead of adding the difference, we're multiplying by the ratio. So this is our preceding, I'm gonna say previous or preceding term. And this is our, the one we're calculating. Hold on, current term at position n. Okay. So that just breaks down that formula. So the current term at position n, the one you're trying to calculate, equals the preceding term times the ratio. Makes sense, right? I mean, we saw this up here, that if we are trying to calculate the 4, that it's the -2 times the ratio, which is -2. -2 times -2 gives you 4. And then if we're trying to calculate, if this one is our term at position n, then we take this guy 4 times the ratio, which is -2, and we get an, which is -8. That's all we're saying here. Okay, so example 1, they want us to write the first 6 terms of the geometric sequence. Easy peasy. They've already given us A1, which is what? 1. And they've told us that our common ratio is a +3. So A2, using our equation, an equals an minus 1 times r. So if we're calculating A2, what's our preceding term? A1, which that's the position. So what's the value at A1? 1. And then what's our ratio? Therefore, A2 is 3. A3. Y'all, I was in the office and one of the second graders came in and I was like, bonjour, Gila. And she said, bonjour. And I was so impressed. I don't know why. It was so cute. Say what? Oh, her name is Jilla. It was for Jilla.
Oh, yeah.
And I just called her Jilla. She's an all-star. That's cool. So anyway, sorry, off topic. Okay, so if I'm calculating A3, then what's my preceding term? Which is 3. Yeah, A2, which is 3, times our ratio, which never changes. And it is 9. All right, A4. 9 times A5, 27 times 3. Hopefully you remember this from like 10 minutes ago when we did it. Yes, 81. And we have our first, so we see this, right? Everybody, thumbs up. Everybody go to this? No? Huh? I forgot what? The first 6. All right, fine. Number 6. Well done, my dear.
Sure.
Because 3 times 8 is 24. but you're actually doing 3 times 80. So 3 times 80 is 240, and then 3 times 1 is 3, and 240 plus 3 is
204. Yeah, I totally solved that in math.
did you?
Yeah.
How did you get that done?
You just go 1 times 3, 3.
It's on the paper.
Right. All right, let's look at example 2, and then we'll move on to our first skill check. And if y'all are writing this as you go, everything I'm doing, I think up to this point is in your book. So not really doing it different. All right, so in this case, they've given us a sequence and they've asked us to find the components that help define the sequence. So we're writing out the geometric sequence formula. Okay, so we have what? 2, 6, 18, 54, 162, and 486. You can see these escalate quickly, right? All right, so yeah, so each one, you found a common ratio. Part A is asking us, what is the term at position 1? 2. Okay, B is asking us, what's our common ratio? Yes, it is a multiplier of 3. C has asked us, what is the term at position 3? 1, 2, 3. The term at position 3 is 18. And what am I talking about? Then they ask for what? A8. 1, 2, 3, 4, 5, 6. Well, first off, this is a 1, 2, 3, 4, 5, 6. So position 6, the term at position 6 is 486 times 3 times 3. Or you can recognize that that's times 3 cubed, which we'll get into that in a little bit. Because see, we're doing it times 3. Let me do it this way. So if I'm trying to calculate A7, because all I know is A6, then it's 486 times 3. So that means that A7 equals, they have it in the book. What is it? No, let me just do it like I'm supposed to. 1,458. So that's A7. That's our next term. 1,458. So that's now A8 equals A7, which is 1,458 times 3. So A8 equals 4,374. No, you'd have to be times 9. Because, yeah. So if you put in your calculator 486 times, no, 486 times 9, you get 4,374. Because 3 times 3 isn't 6. 3 times 3 is 9. And you're multiplying it. So that's why you use exponents. But I have a feeling we're going to be getting to that shortly. 938. Okay, let's do skill check 1. All right. Do number 1 and 2. And if you're feeling froggy, go ahead and do 3, 4, and 5. Let me pause my video. Hold on just a second. Yeah, so let's go ahead and start 1. Except for Rachel, who feels froggy. So she wanted to start number 3. All right, so we want to write the first 5 terms of the following sequences. So they haven't given us the sequence, but they have given us A1, which is 4. And they've told us that our common ratio is what? -2. All right. So A2 equals what? which, yes, it does. How did we get that? A1, which is 4, times the common ratio, which is -2, and we find that our next number is -8. A3 is -8 times -2, which equals, anybody do this one? Yes, we must know that it's positive because we have a negative times a negative. We're not subtracting, are we? Remember, a common ratio involves a common multiplier. So we must multiply times a negative. The term at position 4 equals what? How do we calculate it? Yes, 16 times -2, which gives us what? -32. And then are we just doing 5? Thank goodness. Yes. So A5, what do we need to multiply by each other? Positive or negative? Yes, positive. So our sequence is 4, -8, 16, -32, and 64. It's the rainbow. All right, number 2 gives us, oh, yay, big numbers, right? A1 is, so the term at position 1 is 972. But we have a ratio of 1/3. Oh, good. Yeah, exactly. Exactly. That's all it is. It's division instead of multiplication. You just have to be careful because what if your ratio is 2/3? You multiply by 2 and then divide by 3. So just make sure you recognize that. Okay, so A2 is 972 divided by 3. 3 goes into 9 3 times evenly, so no remainder. 3 goes into 7 with 1 remainder. 3 goes into 12, 4. So A2 is 3. All right, very good. I should have worked that out. Hold on. 972 times 1/3, or 972 divided by 3, right? Those are the same thing. And that gives us 324. A3 is what? Times 1/3. Right, which we can write out as 324 divided by 3. 3 goes into 3. 3 goes into 2. So carry it. 3 goes into 24. Exactly. Yeah, I gotta watch out for that math. 108. Oh. All right. So a term at position 4 begins with what? 108 times 1/3. All right. So 3 goes into 10 3 times with a remainder of 1. So 3 goes into 18. Exactly 6 times. Last one. And then I want us to look at this a little closer. 36 times 1/3 or divided by 3. Right. 972, 324, 108, 36, 12. What are the numbers in our sequence doing? They're getting smaller. So be careful about how you look at these, because if you're looking at a geometric sequence that gets smaller, that means your ratio has to be what? a fraction because you're constantly dividing each previous term, which makes a smaller piece, right? So when we worked with arithmetic sequences, if your numbers got smaller, that meant that you were adding a negative number. That meant your common difference was negative because you're subtracting instead of adding. When you're multiplying, if you have a negative ratio, then you go from positive to negative because you're constantly multiplying by a negative number. When you see a descending value as you go through a sequence like this, where the numbers keep getting smaller, that means that your ratio must be a fraction because you're constantly dividing the previous number into a smaller chunk, right? Okay, sure. We're there. All right, I just wanted to make that distinction. Okay, so for 3, 4, and 5, they want us to find A1. So they want us to find the first term in our sequence, R, which is our common ratio, and then we're looking for A4 and A6. Okay. So the first one, number 3, is 2, 6, 18, and 54. 2, 6, 18, 54. I can't remember if I continued. Okay, I did. All right, so what's A1? What's our ratio? Eh? You did it? Right, each one of these is the preceding number times 3. So our ratio is a positive 3. And then we want to find A4. A4 is 54, which they gave us, right? And then A6 equals, well, we can't find A6 yet, right? What do we need to find? A4, no, sorry. A5 equals A4, which is 54, times our common ratio, which is 3. 286. No, that doesn't sound right. Sorry. 3 times 4 is 12. Carry your 1. 3 times 5 is 15. 162. Oh, you were telling me A6. I apologize. Okay. All right. So now that we have A5, we can find A6, which is 162 times 3. So A6 equals 3 times 2 is 6. 3 times 6 is 18. Carry my 1. 486. Now we are about to learn a recursive formula, and then we're going to learn a explicit formula. So we're going to learn how to do this a simpler way instead of going step by step by step by step here shortly, probably tomorrow. Okay, so let's finish through these though. Number 4 is -7, 14, -28, 56. What should you instantly recognize when you see a sequence like this? You're gonna have a negative ratio. Yes. All right, so A1 is -7. Our ratio is -2. Everybody saw that. A4 is a positive 56. And A6, I'm just going to do it this way. A6 is 56 times -2 squared, which is -2 times -2, which gives you 50. Oh, stop, Meredith. I'm hitting the wrong buttons. 56 times 4. -2 times -2 is 4. And then what is 56 times 4? 224. That sounds right. Because 4 times 5 is 20. And then 4 times 6 is 24. So yeah. And that is our answer. Okay. Last one, number 5. And then I think I'm gonna finish today here. 256, so we can work on some homework together. 128. 64 and 32. All right, so what should you instantly recognize about your ratio here? It's gonna be a fraction. We are dividing. So what's A1? 256. What's the term at the first position? And then the ratio is 1/2, which gets easier to see when you get to that 64 and 32. But yeah, so it's 1/2. And A4 is 32. And A6 is, it's 8. So it's 32, which position 4, times 1/2 squared, which is 32 times 1 squared is 1 times 1, which is still 1. 2 squared, 2 times 2 is 4. So that really is just 32 divided by 4, which is 8. All right, so let's look at the homework. Oh, that was so loud.
I know.
All right, so let's do, what's the homework here? 1 through, okay.
No.
All right, 1 through 10. So homework tonight. Is page 160, 1 through 10 all.
Oh, this is easy.
Yep. For tonight. We'll pick it up tomorrow. All right, so I'm gonna skip 1 and 2 because those are just definitions. We have 10 more minutes. So let's go ahead and see what we can do in 10 minutes. So 1 is just a definition, 2 is just a definition. Easy peasy. I'm not fooling with that. 3. All right, so for 3, 4, 5, and 6, they've given us a sequence. 2, 8, 32. What is it? 128, 512? All right, so A1 is 2. Let me do this differently. That's number 3. Number 4 asks us our ratio, which is what? 4. Yep, it's a positive because we're not alternating positive and negatives. It's a whole number, not a fraction, because we're not getting smaller, getting larger. Okay. What's A4? 1, 2, 3, 4, 128. And then they ask us for A6. So the term at position 6, right. It equals our previous term, 512 times 4. I think so. 4 times 2 is 8. 4 times 1 is 4. We're not carrying anything. And 4 times 5 is 20. So A6 is 2048. That is correct.
I was like, oh, I thought this was all 3, so I put it in a line.
Oh. Okay. So same thing, they give us a sequence of -6, -12, -24, 48, 96. Okay, so number 7 is A1 probably, right? So what's the term in position 1? -6. Okay, number 8. What is the ratio? It is +2. How do we know it's positive?
Because they're all negative.
Right.
And a negative comes negative.
Right. So because they continue to be negative, you know that it's constantly a negative number multiplied times a positive number. So our ratio is a +2. Number 9 asks us for what? Term at position 4. I think they give us that, don't they? What's the term at position 4?
-48. What? Oh, I thought we were talking about 6.
He kept calculating. You said what was number 6? What was
1,000.
No.
192.
1, 2, 3, 4, -48. And you said that position 6, the term at position 6 is 192.
Negative.
There we go. Negative. Yes. I was waiting. All right. Okay, so look, see, you're done. How do y'all feel? That feels easy, right? We got this. All right, so we will pick up on recursive and explicit formulas tomorrow. And we're done.